Welcome to our channel. In this video, we should discuss various properties of determinant. So let's begin. Generally, we use number of properties to simplify our determinant problems. By using properties, one can easily and quickly solve a determinant problem without using any methods of computing value of the determinants. So in this video, we should consider some of the most important properties which should be useful for solving determinant problems. So these properties are: property 1, if all the elements of any row or column are 0, then the value of the determinant is 0. So let's take an example. Suppose A is the determinant whose elements are 2, 4, 3, 0, 0, 0, 7, 8 and 9. It is a case of third order determinant where 3 rows and 3 columns are present. So in order to find out the determinant value of the given determinant, we can use any method, that is, we may use Sar's diagram method, expansion method, minor method or cofactor method in order to find out its value. But there is one property that indicates that if the elements of any row or column are 0, then the value of the given determinant is 0. So as in our given example, all the elements of our second row are 0, so the value of the given determinant is 0. So now come to our second property, that is, if any 2 rows or columns of a determinant are identical, then the value of a determinant is 0. So let's take an example. So A is the determinant having 9 elements, that is 2, 3, 4, 4, 2, 1 and 2, 3, 4. So the value of the determinant can be computed by expanding or by using minor method or by using cofactor method or by using Sar's diagram. But as there is a property that indicates that if the elements of any 2 row or column are identical, then the value of the determinant is 0. So as in the given example, the elements of the first row and the elements of the third row are identical, so our value of the determinant is 0. So now come to the third property of our determinant. So the third property of our determinant is if the rows of a determinant are changed into columns and columns are changed into rows, then the value of the determinant remain unchanged. That means if the rows are changed into columns and columns are changed into rows, then the value of the determinant remains same or unchanged. So let's take an example in order to prove that the value of the determinant should be remain same if the rows and columns are changed. So let's take an example, that is A equals to 2, 4, 5, 3, 2, 1, 7, 2, 8. Now find out A transpose, that is by changing the rows into columns and columns into rows. So our transposed determinant should be 2, 4, 5, 3, 2, 1, 7, 2, 8. Now we can find out the value of the original determinant, and then we should find out the value of the transpose determinant. That is determinant of A equals to, by expanding the first row, we can find out the value of the determinant, that is 4 into 3, 1, 7, 8 plus 5 into 3, 2, 7, 2. Then by simplifying 2 whole into 2 into 8, that is 16, minus 2 into 1, 2, minus 4 whole into 3 into 8, that is 24, minus 7 into 1, 7, plus 5 whole into 3 into 2, that is 6, minus 7 into 2, 14. That is 2 into 14 minus 4 into 17 plus 5 into minus 8. That is 28 minus 68 plus, that is minus 40. That is minus 40 minus 68, that is minus 108 plus 28, that is minus 80. Then find out the determinant value of the transposed determinant, that is determinant of AT, that is 2 into 2, 2, 1, 8 minus 3 into 4, 2, 5, 8 plus 7 into 4, 2, 5 1. So by simplifying 2 whole into 2 into 8, 16 minus 2 minus 3 into 4 into 8, 32 minus 10 plus 7 into 4 into 1, that is 4 minus 5 into 2, 10. That is 2 into 14 minus 3 into 22 plus 7 into minus 6. That is 28 minus 66 minus 42, that is minus 80. So it is proved that the determinant value should remain same or remain unchanged if the rows are changed into columns and columns are changed into rows of a determinants. So now come to our fourth properties. So our fourth property is if any two rows or columns are interchanged, then the numerical value remain same but sign changes. That means if any two rows or columns of a determinant are interchanged, then the numerical value remains same but the sign changes. So let's take an example. Suppose A is the determinant 2 3 8 9 and its value is 2 into 9, that is 18 minus 8 into 3 24, that is 18 minus 24 is minus 6. Now find out the value of the determinant by interchanging the columns. That means we should change the first column and second column. In our new determinant, our first column should be taken as second column and second column should be taken as first column. That means the value of the determinant is 3 9 2 8. So the value of the determinant is 3 into 8 minus 9 into 2, that is 3 into 8 is 24 minus 9 into 2, that is 18. So the value of the determinant is 6. So here the value of the determinant is minus 6, but while we interchange the columns, then the value of the determinant is 6. That means our numerical value remains same but sign changes. Here our determinant value is minus 6, but in case of interchanging the columns, the value of the determinant is plus 6. So the numerical value remains same but sign changes. So now come to our fifth properties. That is if a constant or a number is multiplied with the elements of any row or column, then the value of the determinant is also, then the value of the determinant is also multiplied by same constant. That means if we multiply any constant with the elements of any row or column, then the value of the determinant is also multiplied by the same constant. So let's take an example. Suppose A is 2, 4, 3, 9 and the value of the determinant is 2 into 9 minus 3 into 4, that is 18 minus 12 is 6. So the value of the determinant is 6. Now we should multiply a constant, say 3 should be multiplied with the elements of our first row. So that is 3a equals to 3 into 2 6, 3 into 4 that is 12, 3 and 9. Now we should find out determinant value of the 3a, that is 6 into 9 minus 3 into 12, that is 6 into 9, 54 minus 3 into 12, that is 36. So the value of the determinant is 18. So here we multiply 3 with the elements of first row. So here we are getting the value of the determinant is 6. Now when we multiply 3 the elements of first row, then the value of the determinant is also multiplied by the same constant, that is 18 equals to 6 into 3. So it is proved that if a constant is multiplied with the elements of any row or column, then the value of the determinant is also multiplied by same constants. So now come to our sixth property. Then our sixth property is, if the elements of any row or column is added or subtracted from the respective element of any other row or column, then the value of the determinant remain unchanged. That means if we change the elements of any row or column by adding respective elements of any other row or column of the given determinant, then the value of the determinant remains same or unchanged. So let's take an example. Suppose our original determinant is 2498 and its value is 2 into 8 minus 9 into 4, that is 16 minus 36, that is minus 20. Now we should apply a condition, that is row 2 tends to row 2 minus row 1. So our new determinant is 2, 4 and 9 minus 2, that is 7, 8 minus 4, that is 4. So the value of the new determinant is 2 into 4 minus 7 into 4, that is 8 minus 28, that is minus 20. So in our sixth property, that is if the elements of any row or column is added or subtracted from the respective elements of any other row or column, then the value of the determinant remain unchanged. So now come to our seventh properties. Our seventh property is if each element of any row or column are expressed as sum of two numbers, then the such determinant can be expressed as sum of two determinants of same order. That means if the elements of any row or column are expressed as sum or minus of two numbers, then such determinant can be expressed as sum of two determinants of same order. That means, let's take an example. Suppose our A is the determinant of A plus B, C plus D, E plus F, then M and P, S, T, R. Then it can be expressed as AMS, CNT, EPR plus BMS, DNT, FPR. That means here the elements of first row are expressed as sum of two two numbers. So we can express it as the two determinants of same order. Now come to our eighth properties, that is omega property, that is 1 plus omega square equals to 0, omega plus omega square equals to minus 1, omega q equals to omega, and omega 4 equals to omega. That means we can use the omega properties in case of finding the determinant values of a omega determinants. In that situation, we should use values of the omegas, that is 1 plus omega square equals to 0, omega plus omega square equals to minus 1, omega q equals to 1, and omega 4 is omega. We should use such values to simplify our determinant problems relating to omega. So now come to our ninth property. So our property 9 is the determinant of a product, determinant of product of two matrix of same order is equal with the product of individual determinant. That means the determinant of product of two matrix of same order is equal with the product of individual determinants. That means the determinant of A into determinant of a B is equal with determinant of AB. So let's take an example. Suppose A is the determinant of 2, 4, 3, 2 and B is a determinant of 1, 5, 6, 3. So the determinant value of A is 2 into 2 minus 3 into 4, that is 4 minus 12 equals to minus 8, and determinant value of B, that is 1 into 3 minus 6 into 5, that is 3 minus 30 equals to minus 27. Then determinant of A into determinant of B, that is minus 8 into minus 27, that is 8 into 7 56, that is 6, and 8 into 2 16 plus 5 21. So A into B, that is 216. Now we can find out AB, that is A into B. So by multiplying we should find out the value, that is 2 into 1 plus 4 into 6, then 2 into 5 plus 4 into 3, then 3 into 1 plus 2 into 6, again 3 into 5 plus 2 into 3. So in case of matrix multiplication, we should multiply each row with each column. So first of all we should multiply first row with first column, and then first row with second column. Then second row is multiplied with the first column, and again second row is multiplied with the second column. So that is 2 plus 24, 10 plus 12, 3 plus 12, 15 plus 6, that is 26, 15, 22, 21. Now find out the determinant value of AB. So the determinant value of AB is 26 into 21 minus 15 into 22. So 26 into 21 equals to 546 minus 15 into 22, that is 330. So 546 minus 330 equals to 216. So it is proved that the determinant of product of two matrix of same order is equal with the product of individual determinants. Here we find out determinant of A and determinant of B individually. Then we should multiply their value, that is 216, and again we multiply matrix A and matrix B, that is 26, 22, 15 and 21. Then we should find out the value of the product matrix, that is also 216. So now come to our 10th properties. So now come to our 10 properties, that is, if the elements of any row or column is multiplied with their respective cofactors of any other row or column, then their total is 0. That means if the elements of any row or column is multiplied with the respective cofactor of other row or column, then their total should be 0. That means A11, C21, plus A12 into C22 plus A13 into C23 equals to 0. Here the elements of the first row is multiplied with the cofactors of the second row, then their total should be 0. So let's take an example. Suppose our A equals to 4 2 1 2 3 1 2 1 3. Let's find out the cofactor of the second row, that is C21 equals to minus 1 to the power 2 plus 1 into minor of the M21, that is 2113, so equals to minus 1 to the power 2 plus 1, that is 3, so minus 1 to the power 3 into 2 into 3 6 minus 1, that is minus 1 into 5 minus 5. Then C22 equals to minus 1 to the power 2 plus 2 into M22, that is minus 1 to the power 4 into M22, that is 4 1 2 3, so minus 1 to the power 4, that is plus 1 into 4 into 3 12 minus 2, that is 1 into 10, that is 10. Similarly C23 equals to minus 1 to the power 2 plus 3 into M23, that is minus 1 to the power 5 into M23, that is 4 2 2 1, so minus 1 to the power 5, that is minus 1 into 4 into 1 4 minus 2 into 4 4, that is minus 1 into 0 0. So now we can prove that if we multiply the elements of our first row or third row with the cofactor of second row, then their total should be 0. So now we can prove it. So our first row values is 4 into minus 5 plus 2 into 10 plus 1 into 0. Here the elements of the first row is multiplied with the respective cofactors of second row. So as per the properties, their product total should be 0. So here 4 into minus 5, that is minus 20, plus 2 into 10, that is 20, plus 1 into 0 0. So here plus 20 minus 20 should be cancelled, so the value of the product total is 0. So that means the property 10th that indicates that if the elements of any row or column is multiplied with the respective cofactors of any other row or column, then their product total should be 0. So these are all about our various properties of determinant. So repeatedly watch this video to clear all your doubts and share it with your friends. Thank you.